Littleton Coin Company is ringing in the holiday season with daily deals. Visit littletoncoin.com for at least 15% off select products now through November 28th. Save on your favorite coins, such as Morgan Silver Dollars, Kennedy Half Dollars, commemorative quarters, and much more. But hurry, each day offers a new deal you don't want to miss. Visit us now at littletoncoin.com. That's littletoncoin.com. Littleton Coin Company, serving collectors since 1945.
This is SpaceTime Series 25, Episode 12, for broadcast on the 20th of January 2022. Coming up on SpaceTime, evidence for an internal ocean in the Saturnian moon Mimas. The James Webb Space Telescope commences mirror alignment, and SpaceX launches 105 satellites on a single mission. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Data from NASA's Cassini mission suggests the tiny Saturnian moon Mimas could have a significant subsurface ocean. Our story begins with a scientist setting out to prove that the tiny innermost moon of Saturn was a frozen inert satellite, but instead discovered compelling evidence that Mimas does in fact have a liquid internal ocean. In the waning days of NASA's Cassini mission, the spacecraft identified a curious libration or oscillation in the moon's rotation, which often points to a geologically active body able to support an internal ocean. The study's lead author, Elisa Roden from the Southwest Research Institute in San Antonio, Texas, says if Mimas has an ocean, it represents a new class of small stealth ocean worlds, with surfaces that hide the ocean's existence. One of the most profound discoveries in planetary science over the last quarter of a century has been the discovery that worlds with liquid water oceans hidden beneath layers of rock and ice are common in our solar system. These worlds include the icy satellites of the giant planets, moons like Europa, Titan, and Enceladus, as well as the distant world of Pluto. It means that planets like Earth with surface oceans need to reside in a very narrow range of distances from their host stars in order to maintain the temperatures and atmospheres that support liquid water oceans on the surface. Internal water ocean worlds, however, are likely to exist over a much wider range of distances, greatly expanding the number of habitable worlds likely to exist across the galaxy. Roden says because the surface of Mimas is so heavily cratered, scientists thought they were just looking at a frozen block of ice. Ice moons with global liquid water subsurface oceans, like Enceladus and Europa, tend to be fractured and show other signs of geologic activity. She says it turns out Mimas' surface was hiding this feature, and this new understanding has greatly expanded the definition of potentially habitable worlds both within our solar system and beyond. Liquid water oceans are kept liquid on moons far away from the sun by heat, generated as the moon is alternatively stretched, compressed, and pulled by the powerful gravitational forces of the planet they're orbiting, as well as that of other moons in the system. To match the interior structure inferred by Mimas' libration, tidal heating within the moon needs to be large enough to keep the ocean from freezing out, but small enough to maintain a thick icy shell. Using tidal heating models, the authors developed numerical simulations to create the most plausible explanation for a steady-state ice shell between 22 and 32 kilometers thick, covering a liquid ocean. Now, most of the time, these sorts of models need to be carefully fine-tuned in order to produce something similar to the observations. But Roden says this time, the evidence for an internal ocean just popped out of the most realistic ice shell stability scenarios and observed librations. Roden and colleagues also found that the heat flow from the surface was very sensitive to the thickness of the ice shell, something a spacecraft could verify. For instance, the Juno spacecraft, which is slated to fly to Europa, will use its microwave radiometer to measure heat flows in this Jovian moon. And this data will allow scientists to understand how the heat flow affects the icy shells of ocean worlds like Mimas, which are especially interesting as NASA's Europa Clipper approaches its 2024 launch. Although the findings do support a present-day ocean within Mimas, Roden says it's still challenging to reconcile the moon's orbital and geological characteristics with science's current understanding of its thermal orbital evolution. Evaluating Mimas' status as an ocean moon would benchmark models for its formation and evolution. And this would help science better understand Saturn's rings and mid-sized moons, as well as the prevalence of potentially habitable ocean moons, especially at Uranus. It all comes together to make Mimas a compelling target for continued study. This is SpaceTime. Still to come, the James Webb Space Telescope commences its mirror alignment, and SpaceX launches 105 satellites on a single flight. All that and more still to come on SpaceTime. NASA's James Webb Space Telescope has begun the delicate months-long process of aligning its optics. The fine-tuning operation will turn the orbiting observatory's individual mirrors into one huge, precise telescope. James Webb's primary mirror is a 6.5-metre diameter gold-coated beryllium reflector composed of 18 hexagonal segments. To begin the alignment, engineers first commanded actuators, 126 devices that will move and shape the primary mirror segments, and 6 devices that will position the secondary mirror in order to verify that all are working as expected following the launch. The team also commanded actuators that guide Webb's fine steering mirror to make minor movements to confirm that they're working as well. The fine steering mirror is important because it's critical in the process of image stabilization. Ground teams have now begun instructing the primary mirror segments and the secondary mirror to move off their stowed-for-launch configurations. That means they're moving off their dampening supports which kept them snug and safe from rattling from the violent vibrations of the launch. These movements will take at least 10 days, after which engineers can begin the 3-month-long process of aligning the segments to perform as a single mirror. The James Webb Space Telescope was launched on December the 25th last year aboard an Ariane 5 rocket from the European Space Agency's Kourou spaceport in French Guiana. It's being placed in a 1.5 million kilometre high orbit in what's known as Lagrangian L2 position, a sort of gravitational well on the opposite side of the Earth to the Sun. James Webb's designed to provide improved resolution and sensitivity over Hubble, viewing objects up to 100 times fainter. Unlike Hubble, which observes invisible wavelengths, only just dipping into the ultraviolet and near-infrared, James Webb will concentrate on the infrared end of the spectrum. That's because it'll be looking at objects whose light has been stretched from the ultraviolet and visible part of the electromagnetic spectrum into infrared wavelengths by the physical expansion of space-time as the universe itself has expanded out from the Big Bang 13.82 billion years ago. James Webb will look back through space-time more than 13.4 billion years, allowing astronomers to observe some of the oldest and most distant objects in the universe, including some of the first stars and the formation of the earliest galaxies. And it will allow scientists to study the atmospheres of distant worlds looking for signs of life. Its primary science instruments include a near-infrared camera imager equipped with 10 4-megapixel sensors that'll have a spatial coverage ranging from the edge of the visible into the near-infrared. There's a near-infrared spectrograph with 2 sensors, each of 4 megapixels. A mid-infrared camera and imaging spectrometer designed to measure the mid to long infrared wavelength range. A near-infrared imager and slitless spectrograph for astronomical imaging and spectroscopy, and a fine guidance sensor to control the overall orientation of the spacecraft and to drive the fine steering mirror for image stabilization. James Webb's expected to operate for at least 10 years.
Hi, I'm Ellen Stofan.
And I'm Thomas Serboken.
We're here at the Smithsonian's National Air and Space Museum.
We're talking about the James Webb Space Telescope. Many people have talked about it as the next Hubble, because Hubble has been transformative in our understanding of the sky.
These telescopes use these big mirrors to collect light, which then go into an instrument. So spectrographs are really cool instruments, and they've been used in astronomy and astrophysics for over 100 years.
The spectrographs, of course, having the ability of splitting up the light and looking at the composition of light and actually the originator, whether it's what gases is and so forth.
We have over 100 years worth of spectrographs here at the Air and Space Museum. In 1929, Edwin Hubble actually used a spectrograph to determine the fact that the universe was expanding. We have a spectrograph from the Hale telescope at the Palomar Observatory in California that was used from the 1950s 1960s to the 1970s to look at the redshift of galaxies, of white dwarfs, and that helped us again understand the expansion of the universe. But I'm really fascinated with this issue of using a spectrograph to really understand what materials things are made of, how are they moving, and really just collecting that light, which James Webb will do from very early in the history of the universe.
So if you compare Hubble with Webb, there's really two fundamental changes. The first one is if you look at the mirror, this is 2.4 meters. It's like this, kind of roughly, kind of my height. You look at Webb and it's unfolded, it's 6.5 meters. It's like 3 of me or more, right, with the hand up. So the other thing that's really exciting, the light that we're looking at is actually much, much colder.
And this idea that this super cold temperature and collecting this light with this big mirror is actually allowing you to look back in time as much as 100 million years after the Big Bang, which in the history of the universe, over 13 billion years, 100 million years is really soon after the Big Bang.
Recently, I looked at the album of one of my children's, with all the pictures, and I imagined, suppose I didn't know about the first year, what I would miss about the story of my child. It's now in college. And I think of the universe that way. We have not seen those pictures.
Yeah, like one of the questions I've always found the craziest is this issue of black holes at the centers of galaxies. Right now, pretty much every galaxy we've looked at has a black hole at the center. And so we are really curious about these very early galaxies. Did they already have black holes? Do black holes come later? Do you start with a black hole? Like, how does that work? And that's one of the questions that JWST is really going to go after. And we're actually going to be able to use JWST to start looking at the composition of atmospheres of planets around other stars. And that's really critical in this issue of, are we alone?
Absolutely. Looking at especially cold atmospheres and kind of stars that are there, we can see molecular components, things that relate to life here on Earth, oxygen and so forth. Could you just imagine that? We're about to open that door.
And what I think people don't necessarily appreciate is the way we've had to push technology to get to this point.
Absolutely. And that's the beauty of doing amazing new science. We develop new technologies. So consider this technology that was used to shape the mirrors correctly. That technology right now is being used by eye surgeons around the world. That's just one of the many benefits that come from a development like this.
Just like Hubble, JWST is going to help us rewrite textbooks for years to come.
This is SpaceTime. Still to come, SpaceX launches 105 satellites on a single flight, and later in the science report, a new study shows that despite what the films might say, you really couldn't outrun a T-Rex. All that and more still to come on SpaceTime. SpaceX has successfully launched 105 satellites on a single flight. The company's rideshare program Transporter 3 mission aboard a Falcon 9 rocket took off from Space Launch Complex 40 at the Cape Canaveral Space Force Station in Florida into clear blue skies.
Falcon 9 is in startup. LD, go for launch.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition and liftoff.
Vehicles pitching downrange. 1 gear pressures are nominal.
Power and telemetry nominal.
Falcon 9 has cleared the tower, lifted off from Cape Canaveral Space Force Station. We just heard the call out that the vehicle is supersonic. We're currently going to throttle down the engines in preparation for max Q coming up. So that was the moment of greatest aerodynamic pressure that the vehicle will experience in flight today. Everything looking nominal with stage 1 trajectory. Now we have 5 events coming up in quick succession. MECO, or main engine cutoff, stage separation, stage 1 flip, second engine start 1, and the boost back burn.
It was the 10th mission for the same core stage booster, which successfully returned to Earth, touching down at the Cape's landing zone 1 9 minutes after launch.
We will be attempting to land the booster back on land at landing zone 1. This is known as return to launch site, as opposed to a drone ship landing.
Eco.
Stage separation confirmed. Back startup.
Stage 1, boost back startup.
Second stage MVAC engine has ignited. The first stage is performing the boost back. The first stage flipped itself over and is now making its way back to the coast of Florida. Everything looking nominal with second stage trajectory.
Stage 1, boost back shutdown.
That was the first of 3 burns that the first stage will perform today. The grid fins beginning to deploy. The next event we have coming up is fairing deployment. The 2 fairing halves have separated, fallen away from the vehicle, exposing the 105 spacecraft to the vacuum of space. We will be attempting to recover these brand new fairing halves once they make their way back to Earth. We're currently in the first of 2 MVAC burns. This first one will last until T plus 8 minutes and 26 seconds. The next milestone will be the first stage booster re-entry burn. Falcon 9 executes an entry burn to slow itself down before hitting the dense part of the atmosphere. Without this burn, relying on the atmosphere alone to slow down the Falcon 9 would put unnecessary strain on the rocket.
Nominal trajectory.
Those grid fins have deployed. Falcon 9 has 4 hypersonic grid fins positioned at the base of the inner stage, and they orient the rocket during reentry by moving the center of pressure. Some white puffs of gas coming off from Falcon 9. Those are cold nitrogen gas, which help with attitude control. After first stage landing, the second stage will cut off its MVAC engine and relight it approximately 45 minutes later for deployment of all 105 spacecraft.
Stage 2 FTS has safed.
Stage 1, entry burn startup.
This burn is designed to slow the booster down as it returns through the dense part of the atmosphere.
Stage 2 on nominal trajectory. Stage 1, entry burn shutdown.
Everything continuing to look good with second stage. We'll be attempting to recover this booster for the 10th time today, and we're targeting a land landing at landing zone 1. The first stage has just 1 more burn left, the landing burn.
Yes, it's safe.
It begins just before touchdown and provides the booster a soft descent before landing. About the same time that Falcon lands, we are expecting SECO, or second engine cutoff, 1 of our second stage. Just a few seconds away from landing.
Stage 1 is transonic.
Vehicles traveling around 900 miles per hour really puts the deceleration into perspective. In the span of less than a minute, we'll have reduced from twice the speed of a jet
Stage 1 landing burn.
all the way down to 0 as the rocket lands.
Stage 2 in terminal guidance.
Of the landing back at landing zone 1.
Stage 1 landing like before. Stage 1 landing is confirmed.
As you heard from the call out there and from the cheers behind me, we have successfully landed this Falcon 9 for the 10th time. It's also the 102nd recovery of an orbital class rocket.
Nominal parking orbit.
All right, so we just heard there, second stage had a good orbit. So we cut off or shut down the MVAC engine on the second stage. And as we just heard, we had good orbit. So we're now going to coast for the next 45 minutes or so while we wait for second engine start 2, or SES2.
The payload included a mixture of CubeSats, microsats, nanosats and pocketsats, which were deployed over a 30-minute period into orbit starting at around 536 kilometers an hour after launch. Among the many spacecraft included in the manifest were 44 SuperDove Earth observation CubeSats for San Francisco company Planet. The biggest spacecraft in the payload manifest was the 170-kilogram Ukrainian government Sich-1 Earth observation satellite. There were also 6 Fossasat 2E Internet of Things satellites for Spanish company Fossa Systems, 3 MDA-Sat-1 CubeSats built by the Cape Peninsula University of Technology to protect South African coastal waters from illegal fishing, 8 Tevel CubeSats built by school students in Israel, 5 weather and ship tracking CubeSats for Spire Global, and 4 CubeSats for Canadian company Kepler Communications Data Satellite Relay Network. Numerous radar remote sensing satellites were also part of the manifest, including the 65-kilogram Umbra, which is designed to capture high-resolution radar images, as well as 2 85-kilogram Finland ISI and 2 100-kilogram American Capella remote sensing radar satellites, which will continuously map the world's land masses, oceans and ice sheets. British company Sen included a CubeSat designed to provide high-definition video of the Earth. The Norwegian University of Science and Technology launched a CubeSat equipped with a colour-sensitive hyperspectral imager to monitor the oceans. The first of Arizona company Lunason's new Gossamer Constellation Resources imaging satellites was also launched aboard the flight, as was French startup Unseen Labs' maritime surveillance satellite. Another CubeSat will help city officials in Dubai monitor the city's power and water supplies, while Singapore company's New Space's NUX-1 microsatellite will test new data relay technologies and a new design fuel-efficient ion engine. The satellite uses a Hall effect thruster, in which the propellant ions are accelerated through an electric field. And there's a Taiwanese CubeSat which will test new communications technologies. Also deployed by the Falcon 9 was the Italian company D-Orbit's CubeSat carrier, which will release 6 nanosatellites on its own timetable. These include 4 Polish, 1 Czech, and a University of Southern California CubeSat carrying optical and infrared cameras together with artificial intelligence and machine learning software. Finally, there was a group of 21 so-called Pocket Cube satellites, or PocketSats, which were for customers in the United States, Spain, the United Kingdom, the Netherlands, Argentina, Brazil, Turkey, and Nepal. All in all, an incredibly busy mission. This is Space Time. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study has shown that fewer people who are double-dosed with the Moderna COVID-19 vaccine appear to contract the virus compared to those vaccinated with Pfizer. The findings, reported in the New England Journal of Medicine, are based on research which matched some 200,000 Moderna recipients with the same number of Pfizer recipients in order to track COVID-19 breakthrough infections. 878 COVID-19 infections were recorded in the Moderna cohort, with 3 hospitalized with severe COVID-19, but no deaths or ICU admissions. In comparison, 1,262 breakthrough infections were recorded for the Pfizer cohort, with 7 hospitalizations, no ICU admissions, but 1 death. Meanwhile, a new study has found that a booster dose of the Pfizer vaccine provides over 50% protection against the Omicron variant. The findings, reported in the journal Nature, show that 2 doses of either the Pfizer or Coronavax vaccine gave little neutralizing antibody immunity against the Omicron infection. However, a 3rd Pfizer booster shot secured more than 50% protection from symptomatic infection at 1 month. And a mixed shot regime with Coronavax shots followed by a Pfizer booster at least 4 weeks later resulted in a 1.4-fold increase in antibody neutralization activity against Omicron relative to those who had just 2 doses of Pfizer and Moderna, further endorsing the need for booster shots globally. So far, more than 5.6 million people have been killed by the coronavirus since it first spread out of Wuhan, China. However, the World Health Organization warns that the true death toll is likely to be at least double that amount, as there are now over 340 million confirmed COVID-19 cases globally. Physicists have successfully created a physical simulation of an exotic and elusive state of matter first predicted back in the 1970s, called spin liquid. Spin liquids contain arrangements of electron spins, a subatomic equivalent of bar magnets, in a solid material that's intrinsically unstable, like molecules in a liquid. The findings, reported in the journal Science, stress that while their existence is still preliminary, researchers have been able to simulate them using atoms suspended in a vacuum. Well, bad news for anyone trying to outrun a T-Rex. New computer modelling shows that the flesh-eating 2-legged dinosaurs could run at speeds of up to 45 kilometres per hour. The study is based on a series of tracks made by an agile, medium-sized cousin of the T-Rex. The findings, published in the journal Scientific Reports, represent some of the fastest running speeds ever calculated from footprints from dinosaurs and shed new light on the way they moved. The extreme left and right of politics are both loaded with conspiracy theorists who are the useful idiots, as Lenin would call them, used by major global players on both sides. On the left, there are groups like Antifa, and the right, of course, has QAnon. Tim Mendham from Australian Skeptics says studies tell us that the less people feel in control of their own lives, the more likely they are to believe that there is a conspiracy against them.
Brian Dunning, of course, has the Skeptoid podcast in which he looks at a whole range of different paranormal phenomena. So he does these 3-minute explanations of things, and he's done one of QAnon, which of course doesn't need much explaining. QAnon is based on a whole lot of weird paranoia. Obviously, the main premise is that the world is being run by a cabal of people, of politicians and celebrities and Jewish bankers and Democrats, of course, who are all plotting against everyone else, and they're having satanic rituals with pedophilia and children being kidnapped, etc. Q is supposed to be a particular person, an actual real person within the CIA or the government who issues these
or the Q
coded
continuum.
Or the Q continuum or whatever. No one's quite sure because no one's even quite sure if Q is real or is one person or several people, but he puts out coded messages, which is basically getting on his keyboard and just tapping away, tapping anything.
Managed to get a lot of very gullible people to believe a lot of garbage.
And the trouble is, it's more than just gullible. They will actually go out and do things because of what Q supposedly says, including the famous case of the pizza shop, which supposedly had a basement where these satanic rituals were occurring. So someone went and bombed it or shot it up or whatever. The fact it didn't have a basement at all was beside the point. So, I mean, it's the sort of world where you can say anything. You make up any theory and some idiot out there is going to act upon it. And 3 minutes explanation by Brian Dunning for a phenomenon that's been going for a number of years now, which is in Australia too. I mean, people carry the Q symbol around in Australia as well as anything. And it's just fabricated nonsense. But it's become such a serious issue.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.